These are the lesson activities for Math 117 for sections 4.4 and 4.5, which are on Webster's method and the Huntington-Hill method of apportionment. Okay, number 1, a small country consists of 5 states, A, B, C, D, and E. We're going to apportion 40 seats in the legislature using Huntington-Hill. You will not need a modified divisor for this one, so that makes this pretty straightforward. Okay, so 34,800. We add up all of these populations to get the total population, and we get 400,000. Then we have to calculate the standard divisor, which is the total population, 400,000, divided by 40 seats. That tells you how many people per seat, and that comes out to 10,000. So the standard divisor is 10,000. We calculate the standard quota by dividing each state's population. So for state A, it would be 34,800 divided by 10,000, and we get 3.48. We do this for each state, so we would have 10.48, 6.48, 14.08, and 5.48. Now, as a check, we should add these all together. When you're doing the standard quotas, it's not necessarily true for modified quotas, but when you're doing just the standard quota, if you add them all up, you should get the total number of seats, 40. If you don't, you know you made a little mistake somewhere. Okay, so next we do the lower quota and the upper quota. So the lower quota is round down, upper quota is round up. So 3 and 4, 10 and 11, 6 and 7, 14 and 15, 5 and 6. Adding those up tells you nothing. Okay, so the geometric mean of the lower quota and the upper quota, to get that, you multiply the two together and then square root. So the square root of 3 times 4 is 3.464. The square root of 10 and 11 is 10.488. And the square root of 42 is 6.4807. A question I get a lot is how many decimals do you need here? You need enough decimals to be able to compare this number to this number. So if I had rounded this to 6.48, at the step where I have to decide how to round, I need to compare this number to this number. But they look the same if I had rounded this one, but they're not the same, right? This, the geometric mean is actually 6.48074, which makes it a little bit bigger than 6.48. So you need just enough decimals to be able to compare it to the standard quota. So for this one, I did 10.488 so that I could tell that this decimal is bigger than this decimal, which is 10.480. Okay, continuing on, the square root of 14 times 15 is 14.49. And the square root of 5 times 6 is 5.477. And it's important that I didn't round that up to 5.48 because then it would look like these two values were the same when in fact this number, 5.477, is a little bit smaller than 5.48. Okay, so we don't bother adding those up either. Now Huntington-Hill rounding has you compare the standard quota to the cutoff. Okay, so these numbers, these geometric means, these are the cutoffs. If my standard quota is below it, you round down. If the standard quota is above the cutoff, round up. So I'm going to compare 3.48 to 3.464. 3.48 is above this cutoff value, 3.48 is bigger, so I'm going to round up to 4 because my quota is above the cutoff value. Now 10.48 is below this cutoff value. 10.48 is smaller than the cutoff of 10.488. So in this case, I round down to 10. Now 6.48 is a little bit smaller than the cutoff value of 6.48074, so I round down to 6. 14.08 is below the cutoff of 14.49, so I round down to 14. And 5.48 is a little bit bigger than the cutoff value of 5.477, so I round up to 6. And when I add these up, 10 and 4 is 14, and 6 is 20, and 14 makes 34, and 6 makes 40. I've given out exactly 40 seats, so I don't have to adjust my divisor. This is just the answer in this case. Okay, so to compare, we're going to apportion the 40 seats again. This time we're going to use Webster's method, which is a modified divisor method, and I just told you what divisor works so that we won't have to waste time searching for it. 9,965 works. But we start the same way we did with Huntington Hill. Calculate the standard divisor. It's 10,000. We get standard quotas by dividing every state's population by 10,000, 3.48, 10.48, 6.48, 14.08, and 5.48. That's exactly 40 seats. Okay, so now we round. For Webster's, we just use standard rounding. Below 0.5 rounds down, 0.5 and above you round up. So the cutoff is 0.5 for Webster, whereas with Huntington Hill, the cutoff is an ever-changing value. It's different depending on your lower and upper quota. For Webster, it's just always below 0.5 round down, above 0.5 and above round up. So when I round these, I'm gonna go down. So I have 3, 10, 6, 14, and 5. So I rounded everything down because all of my decimals were smaller than 0.5. When I add these up, I get 13, 19, 29, and 4 is 33, and 5 is 38. I only gave out 38 seats. That's too small, right? Too small, so make the divisor smaller. So instead of using the standard divisor of 10,000, I'm going to use a smaller divisor. 9,965 was given in the hint that works. Okay, so I am going to divide each state's population by this new divisor. 34,800 divided by 9,965, and we get 3.492. Okay, I went ahead and did all of those divisions, each state's population by the new modified divisor, and I got the modified quotas, which we don't bother adding because it doesn't tell us anything. Now we're going to round. Standard rounding, Webster's method. We just do the normal rounding that you learned at some point in your previous math education. So 3.492. 0.492 is less than 0.5, so we round down. Then 10.517, that goes up, up, down, down. And when I add these up, I get 14 plus 7 is 21, plus 14 is 31.35, plus 5 is 40. So I gave out exactly 40 seats. That's my result using Webster's method. Were our apportionments the same or were they different? So they're a little bit different. So we have 4 and 3, 10 and 11, 6 and 7. The 14s are the same, and then a 6 and a 5. So these are different. Why do we think it happened? Why did they come out differently? Because many of the standard quotas were very close to 0.5. So that means that when you're doing a geometric mean as a cutoff, you might sometimes round in a different direction than Webster's would have you round. They were different because the standard quota decimals were very close to 0.5. In general, Huntington Hill and Webster's are more often the same, right? It just so happens this was a very contrived example to make them different, where I tried to make it so that the decimals were very close to 0.5. But typically, they're not, which means that if your decimal was 0.2, you'd round down either way, because the geometric mean is typically close to 0.5. In general, what do you think of Huntington Hill in comparison to Webster's? So my mnemonic for how to remember these, with Huntington Hill, I call it what the hill kind of rounding rule is that? Because it's ridiculous. It takes a lot of extra effort, much more intensive effort and time. So why? And the results are almost always the same as Webster's. So I think Huntington Hill, despite being the method that we use right now to apportion the House of Representatives, is not as good as Webster's. It's just an opinion, but I like Webster's. It's very easy to understand, and it's pretty straightforward. And it almost always gives the same result as Huntington Hill.